Today we're going to learn how to compare two sets of data using measures of center and spread. You should be on page 12 in your notes packet. Measures of center are those measures that describe the middle of a data set, and these are used to describe the typical performance of a data set. So the measures we use for this are mean, median, and mode, although we typically use mean and median the most. Measures of spread describe how far apart the data is, or how spread the data is. Measures of spread you'll also see referred to as measures of variability, or even measures of variation. So you'll see all of these words and you need to know they mean the same thing. So again, they show how spread apart or how far apart your data is, and they are used to describe the consistency. Consistency is just another way of saying how reliable your data is. If you have a lower measure of spread, it means that your data actually has a better consistency because it's much closer together and it's more predictable. The measures of spread that we focus on are range and interquartile range. Let's look at two different sets of data. The first set of data is test scores. Well, we know that when we are finding sets of data, or measures of the center and spread of sets of data, the first thing we need to do is always order our sets of data from least to greatest. Check your sets of data and make sure that they are ordered correctly, and make sure that you didn't skip any numbers. Remember that if a number shows up more than once in your data set, you do have to write it more than once when you order your numbers. All right, for the question one says how many people took Miss Jackson's math test and how many people took Mr. Dunson's math test. Well, each of these numbers represents a test score, so we can count these to figure out how many took each test. So for Miss Jackson, we can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 test scores. So that means that 11 people took Miss Jackson's test. For Mr. Dunson, we can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 test scores. So that means that 12 people took Mr. Dunson's test. Number 2 says, what is the range of scores in both classes and whose class has the highest range? So what conclusion can you make? Well, remember range is greatest minus your least subtracted from your greatest. I apologize. So for Miss Jackson, her greatest test score was 97 and her lowest test score was 65. So for Miss Jackson, we would do 97 minus 65, which would give us 32. So Miss Jackson has a range of 32. For Mr. Dunson, his greatest test score is 100 and his least test score is 64. So we would do 100 minus 64, which would give us 36. Well, when I look at this, I can see that Mr. Dunson has a higher range than Miss Jackson. Now, because that range is highest, remember range is a measure of spread. So because Mr. Dunson's range is highest, that means that his data is more spread out than Miss Jackson's. So I can say Mr. Dunson's test scores are more spread out than Miss Jackson's, which means that his test scores are less consistent. Another way of saying this is that they are less reliable or less predictable. Because his numbers are a little bit more spread out than Miss Jackson's, it might be harder for us to predict a test score for Mr. Dunson's class than for Miss Jackson's class. Number 3 says, what is the mean score for both classes and how do they compare? Well, remember to find mean, we add up all the values in our data set. So for Miss Jackson, we would add 65 plus 72 plus 79 plus 81 plus 81 plus 82 plus 84 plus 89 plus 93 plus 95 plus 97. Once you add everything up, you have to divide by the number of items in your data set. So we remember that Miss Jackson, when we counted her test items, she had 11. So we would add all of these up and then divide by 11. So I'm going to just put this into my calculator and add everything together. When I do that, I get 918. Then I'm going to take 918 and divide by 11. Well, when I do that, you'll notice that we get 83.45 and the 45 repeats. So we can put a bar over that to show that it repeats. Now we're going to do the same thing but with Mr. Dunson's test scores. So Mr. Dunson has all of these scores, which we're going to add together. And then for Mr. Dunson, we need to divide by the total number of items that were in his data set, which for Mr. Dunson, remember, was 12. So I'm going to put all of this into my calculator. 64 plus 73 plus 74 plus 77 plus 79 plus 81 plus 88 plus 93 plus another 93 plus 96 plus 100 and plus another 100. Well, when I do that, I get 1018, and I need to divide that by 12 since there were 12 numbers in the data set. Well, for this, I get 84.83, and I notice that the 3 repeats, and only the 3 repeats, so I'll put a bar over just the 3. Now, mean is a measure of center, which means it tells us about the typical performance of a data set. So I noticed that Mr. Dunson has a larger mean than Miss Jackson. So since this tells us typical performance, I can say that since his mean is greater, Mr. Dunson's students typically have higher test scores than Miss Jackson's. So my comparison is Mr. Dunson's test scores have a greater mean than Miss Jackson's, which means that students in his class tended to perform better on this particular test. Number 4 asks what is the median score for both classes and how do those compare? Remember, the median is the number or numbers that are in the middle. Now, we always have just one median. Sometimes you'll have 2 numbers in the middle, but you have to find just one of those. So we'll look at several examples. So when I'm trying to find the median, I always take away a number from the front and a number from the back at the same time. So for Miss Jackson, I would take 65 and 97. Then I would take 72 and 95, then 79 and 93, then 81 and 89, then 81 and 84, and now you'll notice I only have one number left in the middle. That means that 82, this 82, is the median of the data set. So Miss Jackson's data has a median of 82. Now we'll do the same thing with Mr. Dunson's. So we'll take away a number from the front and back, so 64 and 100, then 73 and 100, then 74 and 96, 77 and 93, 79 and 93, and you'll notice that at this point there's only 2 numbers left. So if I took them both away, I wouldn't be left with anything in the middle. But I already told you you cannot have 2 medians. Well, when this happens, there's actually an invisible median and it's right in between these 2 numbers. So 81 would not be the median and 88 also would not be the median. The median is just this number between them. So to find it, what we would do is average these 2 together. So I would add 81 plus 88, and then I would divide by 2. Well, when I add 81 plus 88, I get 169. Then I would need to divide that by 2, and I get 84.5. So that means that Mr. Dunson has a median of 84.5. So when I compare these, again, a median is a measure of center, which means it tells us about typical performance. So again, Mr. Dunson's median is higher than Miss Jackson's median. So that tells me that his students typically, again, score higher on this test. So the comparison I write is Mr. Dunson's test scores have a greater median than Miss Jackson's. which means that students in his class tended to perform better on this test. Number 5 asks what is the mode for both classes and how do they compare? Well, remember mode is the number or numbers that occur most often. So for Miss Jackson, you see that we have 81, which occurs 2 times, and every other number in the data set only occurs once. So Miss Jackson has a mode of 81. When I look at Mr. Dunson's data set, all of the numbers occurred once, but then you have 93 occurring twice and 100 occurring twice. Well, those both occur twice, so we would say that those were both the mode. When I compare Mr. Dunson's mode to Miss Jackson's mode, both of those numbers are greater than Miss Jackson's mode. So I would say Mr. Dunson has a greater mode than Miss Jackson. The thing about a mode is that it doesn't necessarily tell us much in way of comparing the two data sets, but we can just say that his mode is greater. Number 6 says, based on the score, which measure of center would be the most accurate estimate of the test scores for each class? Well, if there's no outlier in the data, and remember an outlier is a number that is much greater or much smaller than the rest of the numbers. So if I look at Miss Jackson, her smallest number is 65 and then it goes to 72. Well, 65 and 72 are pretty close, and her greatest number is 97 and then it goes to 95, and those are also very close. So I would say there's no outlier for Miss Jackson. Mr. Dunson goes from 64 to 73, again, pretty close. And 100 to 100, they're the same number. So there is no outlier for Mr. Dunson either. Because there's no outlier, I would say that the mean would be the best estimate. This is because when there is no outlier, the mean should always be used to describe your data. If there is an outlier, then you're going to use the median instead. But for this set of data, there is no outlier, so we would use the mean because that is the most accurate estimate. Number 7 asks, what was the interquartile range for each class and what does this tell us? Well, to find interquartile range, the first step is to find the median. Well, we did that already actually in our previously. We found that 82 was Miss Jackson's median, and we found that there was a median somewhere between 81 and 88 for Mr. Dunson. Now 2 is to split the data into a lower half and an upper half. When I split Miss Jackson's data, I'm going to go from 65 to 81. I'm not including 82 because 82 was that median right in the middle. When I split Mr. Dunson, I'm going from 64 to 81 because even though I used 81 to find the median, 81 was not the actual median of that data set, so it does not get used as the median. That's the same for the upper half. 88 was not the median, so I'm putting it in my upper half of data. Now, part 3 is to find the medians of both halves. So when I look at Miss Jackson, if I'm finding the median of this lower half, I would again take a number from the front and from the back. So 65 and 81, then 72 and 81, and I'm left with 79 in the middle. This is going to be called my first quartile, or Q1. Then I do the same thing with my upper half. So I'm going to take one from the front and one from the back, then 81 from the front, one from the back, and I'm left with 93. That's called my third quartile. Technically, the median is your second quartile. To find the interquartile range, you are going to subtract your third quartile minus your first quartile. So for Miss Jackson, I'm going to do 93 minus 79. Well, when I do that, I get 14. So Miss Jackson has an interquartile range of 14. For Mr. Dunson, we're doing the same thing, but we've got to find our medians of our upper and lower halves. So for our lower half, we're going to do 64 and 81, then 73 and 79. we notice that we have two numbers in the middle. Well, when we have two numbers in the middle, we have to add them and divide by 2. So we're going to do 74 plus 77, which gives us 151, and then we'll divide that by 2. When we divide that by 2, we get 75.5. So this is our first quartile for Mr. Dunson. Now we need to find the third quartile, which again is the median of the upper half. So we're going to find one number from the front and one from the back until we get to the middle of our data set. Again, you'll notice there are two numbers in the middle. So we're going to add them together, then divide by 2. Well, when we add 93 plus 96, we get 189. Then we're going to divide 189 by 2, which gives us 94.5. So this is the third quartile for Mr. Dunson. Now to find his interquartile range, we take both of those numbers and we subtract them. So 94.5 minus 75.5, which gives us 19. So that means Mr. Dunson has an interquartile range of 19. Now remember, interquartile range is a measure of spread, so it talks about consistency. Since Mr. Dunson has a higher measure of interquartile range, that means his data set is more spread out. So that means that his is less consistent or less reliable than Miss Jackson's. So my conclusion for this will say Mr. Dunson's interquartile range is greater than Miss Jackson. This means that his data is more spread out, which means that it is not as consistent as Miss Jackson's. Now let's look at another set of data. This set of data shows the number of siblings that students in each class have. The first thing we're going to do is order our data sets from least to greatest. When I look at Miss Yolanda's data set, it should be 0, 0, 1, 1, 1, 1, 1. So there should be 5 ones. Then 2, 2, 2, so 3 twos. Then 3, 4, 5, 7, 8. For Mr. Tate, you should have 0, 0, 1, 1, 1, 1. So that should be 4 ones. Then 2, 2, 2. So that should be 3 twos. Then 3, 3, 3, 3, 3. So that should be 5 threes. Then 4. Then 5, 5. How many students are in each teacher's class? Well, each of these numbers represents the students in the class, so we would count. For Miss Yolanda, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 students. For Mr. Tate, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 students. Number 2 asks, what is the range and what conclusion can we make? Well, remember, range is the greatest minus the least. So for Miss Yolanda, the greatest is 8 and the least is 0. So we would do 8 minus 0, which would give us 8. For Mr. Tate, the greatest is 5, the least is 0. So we would do 5 minus 0, which would give us 5. Now, because Miss Yolanda has a greater range than Mr. Tate, that tells us that her data is more spread out. That means it is not as consistent or not as reliable as Mr. Tate's. So we will say Mr. Tate's class has a smaller range, which means the number of siblings is more consistent for his students. Number 3 asks, what is the mean number of siblings in both classes and how do these compare? Well, to find mean, remember, mean is another word for average. So the first thing we're going to do is add all of the numbers together for each person, and that includes the zeros. So for Miss Yolanda, we'll add all of these together. And then we're going to divide. Well, we divide by the number of items in the data set. And remember, Miss Yolanda had 15 numbers in her data set. So when I add all of these together, I'm going to get 38, and then I'm going to have to divide that by 15. So when I do 38 divided by 15, I'll get 2.53, and the 3 repeats. So I'll put a bar over that 3. Now I'll do the same thing for Mr. Tate, so I'm going to add all of his numbers together. And then I'm going to divide for this one by 17. So when I add all of these together, I get 39, and I'm going to do 39 divided by 17. And you'll notice we get a very long number for that. So we're just going to round that one, and it's going to be about 2.29. Well, remember a mean, it tells us the typical performance of a data set. And I can see that Miss Yolanda has a mean of about 2.53, and Mr. Tate has a mean of about 2.29. So Miss Yolanda's is slightly larger. So I would say that students in Miss Yolanda's class typically have more siblings than students in Mr. Tate's class. Number 4 asks us to find the median, and remember median is that number in the middle. So for Miss Yolanda, we'll take away a number in the front and the back until we get all the way down to the middle. Well, when we get to the middle, we see that we have 2. And so for Miss Yolanda, it's this first 2 in her data set. So Miss Yolanda has a median of 2. For Mr. Tate, we'll do the same thing, cross out a number from the front and back until we get all the way down to the middle. Well, for Mr. Tate, you notice that our median is also 2. For Mr. Tate, it's the last 2. Since they're the same, I'm just going to say both classes have the same median number of siblings. What is the mode number of siblings in both classes, and how do these compare? Well, for Miss Yolanda, we can see that for the number 0, that happens twice. For the number 1, it occurs 5 times. The number 2 occurs 3 times. And then 3, 4, 5, 7, and 8 only occur once. Well, since 1 occurs the most number of times out of all of those, 1 is going to be the mode for Miss Yolanda. For Mr. Tate, you can see that the number 3 occurs the most number of times, so Mr. Tate will have a mode of 3. So when I compare those, Mr. Tate's class has a greater mode than Miss Yolanda's class. Based off the number of siblings, which measure of center would be most accurate? Well, for Miss Yolanda and Mr. Tate, neither of them seems to have an outlier. And since neither has an outlier, mean would be the best measure of center to use. Then number 7 asks us to find the interquartile range. Remember, to find interquartile range, we have to find the medians first. Well, this first 2 for Mr. Yolanda was her median. And for Mr. Tate, the last 2 was his median. Then we had to split each data set up into a lower half and an upper half. So that's the halves for Miss Yolanda. These are the halves for Mr. Tate. Remember, the median does not get included, but if there were 2 numbers in the middle, those do get included. Now we find the median of each half. So for Miss Yolanda, we would take away 1 from the front and back until we got to the middle, which would give us 1 for this data set. Then for this part, front and back, front and back, front and back, and we'd be left with 4. Well, we take these because this is our first quartile and this is our third quartile, and we would subtract. 4 minus 1 would give us 3. Now we do the same thing for Mr. Tate. So we're going to take 1 number from the front and 1 from the back of each half until we get to the middle. Well, for Mr. Tate, you notice we have 2 numbers in the middle, so we would take both of those and add them together, then divide by 2. Well, 1 plus 1 is 2, so 2 divided by 2 gives us 1. Then we do the same thing with the upper half, 1 from the front and 1 from the back until we get to the middle. Well, when we get to the middle, again, there are 2 numbers, so we would add them together, then divide by 2. Well, 3 plus 3 is 6, and 6 divided by 2 gives us 3. So our first quartile is 1, and our third quartile is 3. So we're going to do 3 minus 1, which gives us 2. Now, interquartile range is a measure of spread, so this tells us how far apart the data is spread out in that data set. Since Mr. Tate has a smaller interquartile range, that means his numbers are closer together, so they are more consistent.